Okay, in this video, I'm going to show you how to determine the rate law for a complex reaction that involves two reactants coming together. So here's our generic reaction where A reacts with 2B to form C plus C. It's really important to note that this is the balanced chemical equation, and the balanced chemical equation and coefficients have nothing to do with the order of the reaction at all. You need to determine the order of the reaction experimentally, and those experiments are shown over here. So what we need to do is determine the order of the reaction with respect to both reactant A and reactant B. So what we're ultimately looking for is the rate law, in which the rate is equal to the rate constant K times the concentration of A to its specific order, and I'm going to just put it in as a variable M right now. We're going to determine M, times the concentration of B to its specific order, and I'm going to call that variable N. So we are looking for M and N, and we need to determine those using the experimental data. So the first thing that we're going to do is determine the order of the reaction with respect to reactant A. So looking at the experimental data, the experiments that we are going to use to determine the order of the reaction with respect to A are the experiments in which B is held constant. We want to know how the rate changes when only the concentration of A changes and when B is held constant. So looking at this, we can see that in experiment 2 and in experiment 1, the concentration of B is held constant. The concentration A has been doubled. So we're going to use the ratio of the rates is equal to the ratio of the concentrations to the order. So we're going to look at experiment 2 over experiment 1 because B is held constant. And I put experiment 2 on top just because it's a bigger number. So we're going to deal with whole numbers and not fractions. So it's the ratio of the rates. So in this case, we have the rate of 3.5 in experiment 2 divided by the rate of 1.8 in experiment 1 is equal to the ratio of the concentration of A, 5, divided by 2.5 to that order with respect to A, which I'm calling M. So now we just solve this. You get 2 equals 2 to the order of M. M is equal to 1. If we look at another set of experiments, we should get the same answer. So the next set of experiments we can use to determine the order of the reaction with respect to A is experiments 3 and 4 because B is held constant. So any change in the rate is going to be due to the change in concentration of A. So then in this case, it would be experiment 4, because it's a larger number, divided by experiment 3. So 7 divided by 3.5 is 2, equals 5 divided by 2.5, 2 to the order of M. So M is equal to 1. So that's the order of the reaction with respect to A. Now we're going to look and determine what is the order of the reaction with respect to B. So now we need to hold the concentration of A constant so that any change in the rate comes from the change in concentration of B. So holding A constant, we can see that experiment 3 and in experiment 1, the concentration of A is constant. We have the concentration of B changing. So we're going to put experiment 3 divided by experiment 1. So the ratio of the rates, so in experiment 3, the rate is 3.5, divided by the rate in experiment 1, 1.8, is equal to the ratio of the concentration, 6 divided by 3, to the order of N. So 2 equals 2 to the order of N. N equals 1. You can do the same thing looking at our other set of experiments. So experiment 4, the concentration of A is 5, and in experiment 2, the concentration of A is 5. So looking at the order with respect to B, hold A constant. So it would be the ratio of the rates, 7 over 3.5 is 2, equals the ratio of the concentration, 6 divided by 3 is also 2, to the order of n. You also get n is equal to 1. So now we can rewrite the rate law for this reaction. Rate is equal to rate constant K times the concentration of A to the first power times the concentration of B also to the first power. Most of the time we don't write the ones because anything to the first power is itself, so you can also write it as rate equals K times A times B. So in the mechanism of this reaction, and we'll get there eventually, 1 molecule of A reacts with 1 molecule of B in the slow step. Please again note that it has nothing to do with the coefficients. The coefficient on B is 2, but that is not the order of the reaction. And finally, one more thing. It is first order with respect to A and it is first order with respect to B, but this is overall a second order reaction. You get that because N plus M equals 2, 1 plus 1 equals 2. So overall it is a bimolecular reaction. Again, where 1 molecule of A and 1 molecule of B react together in the slow step.